Hi guys, welcome back to Calculus with Mr. Robeson here. We're just going to look at graphing more curves using the function, the derivative of the function, and the second derivative of the function in this video. That's it, just more examples of curve sketching. Alright, so here we go. We want to analyze and sketch the graph of this function here. So the first things we want to get are the things that we can get from the original function. So we want to try and get any y-intercepts and x-intercepts. So y-intercept is again when x equals 0. So we're going to just plug in 0. We get 4 on top, we get negative 2 on the bottom, so we get negative 2. So we get the point 0, negative 2. There is a point on our graph. X-intercepts are when y equals 0. So we're setting our function equal to 0. Well, it's going to equal 0 when the top equals 0, and when the bottom's not equal to 0. All right, we could probably just take a quick gander at the domain here, just to make sure we know. Our domain is the bottom can't equal 0, so we get x cannot equal 2, which also means we have a vertical asymptote at x equals 2. So if we get 2 for an answer, we know not to include it here. All right, so the fraction will equal 0 when the top of the fraction equals 0. And does that factor? Factors of 4 that add to make 2? Doesn't look like that's going to factor for us. In fact, I don't think that's ever going to be equal to 0. I think that's always going to be positive. If we want, we can use the quadratic formula to check. All right, but I don't think it's ever going to equal 0. All right, so we took care of domain. We're not going to worry about trying to find range. Continuity, we got our vertical asymptote. So there's that. The other thing we can get here are horizontal asymptotes. So real quick, we can take a limit as x goes to infinity of x squared minus 2x plus 4 over x minus 2. All right, the highest power on top, this is a trick we can only do when we go to infinity, is x squared. The highest power on the bottom is x. So this basically is going to x, and x is going to infinity. So we've got no horizontal asymptote going in the positive infinity direction. As we go to negative infinity, it's basically going to be the same thing, like the same exact process over x minus 2. We're going to look at the highest power on top over the highest power on bottom and their coefficients. We get x, and we already said x is going to negative infinity, so we have no horizontal asymptote that way. But we do know we're going down this way, and we're probably going to be going up to the right, down to the left, up to the right. So that's everything we can get from the original function. So that's all the way up to here. So that's all of this stuff. Oh, I guess we didn't do symmetry. So we can check symmetry. We don't always have to check symmetry. I usually don't do the checking of symmetry, but let's check it just in case. Sometimes it's helpful. All right, so this one cancels out. This one doesn't. This one doesn't. So we're not getting that it equals f of x or that it equals negative f of x. So we don't have any symmetry. Well, do we? No, we don't. So we have no symmetry happening here. It may be somewhat symmetric looking in some way or shape or form, but it's not exactly symmetric in any sort of way, it looks like. All right, so next up, so that's all that stuff. So next up, we want increasing and decreasing. So increasing and decreasing means we need to take a derivative. So let's try and find our derivative here, f prime of x. So our derivative here is another quotient rule. So we get the bottom times root of the top, which is going to be 2x minus 2, minus the top, all that, x squared minus 2x plus 4, times root of the bottom, which is just 1, all over the bottom squared. All right, we probably want to multiply some of this out because we're going to get some like terms that we can simplify. So if we multiply this top out, we're going to get, let's see, we're going to have 2x squared. First, outer, we're going to have a minus 2x. Inner, we're going to have a minus 4x. Last, we're going to have negative 2, and negative 2 is 4. Then we're going to distribute the negative here, so we get minus x squared plus 2x minus 4. All right, the bottom I'm just going to leave. I like it factored as it is. We pretty much always just leave the bottom when we do quotient rules. So we've got 2x squared minus an x squared. So that gives us just an x squared. So there's our x squared guys together. We've got a minus 2x, a plus 2x. They cancel out. and a minus 4x. So we still have the minus 4x. So now that's gone. We've got a plus 4 and a minus 4. Well, those cancel out. All right, so there's all of our top right there. Looks like we can factor out an x from that. The bottom is still x minus 2 squared. If we factor out an x, we get x minus 4 over x minus 2 quantity squared. So there's our derivative. Now we want to find its relative extrema and where it's increasing and decreasing. So that means we need to find all the critical values. So on top, we're getting x equals 0 and 4. On the bottom, we're getting x equals 2. So remember, 2 is a vertical asymptote, so it's not going to be a relative extrema. All right, so now we need to check out our number line chart here. Let's see if I can fit it down here. So we've got to have those numbers in order. So 0 goes first, then 2, then 4. Our factors are x minus 4, and x minus 2 quantity squared. All right, sometimes I put factors together, sometimes I separate them. It's personal choices. So if we plug in a negative number, x is negative. If we plug in a positive number, it's positive. X minus 4, if we plug in a number down here, it's going to be negative, still negative, still negative. But if we plug in a number bigger than 4, it's positive. X minus 2 quantity squared, this squared part is going to make it positive in all of its sections. So if we put our signs together to make f prime, we get two negatives cancel out, and we get the positive, negative, negative, positive. So that means f, which I don't think I can fit down there, but f would be increasing. I'm just going to draw over it. Decreasing, decreasing, increasing. So remember at 2 we've got our vertical asymptote, so we don't have anything there, but here it looks like we've got a max. And right here at 4 it looks like we're going to have a relative min. All right, we can find those points if we want by just plugging them in. We already have 0, negative 2 as a relative max. And if we plug in 4, I don't think we've plugged in 4 anywhere yet, but let's do f of 4 to see what we get for a point there. We get 16 minus 8 plus 4 over 4 minus 2 is 2. So that's 8 plus 4 is 12 over 2 is 6. So we got the point 4, 6 is a relative min. All right, seems weird that 0, negative 2 is a max and 4, 6 is a min, but they're different sections of the graph. So just don't try and compare y values. All right, so let's see. Here's our derivative, and now we need a second derivative. All right, so let's change colors here. I haven't used green yet. X times x minus 4, x minus 2 squared. Derivative from the other side, our f prime was x times x minus 4 over x minus 2 squared. We've got to do a quotient rule with that to find our second derivative. So it's going to be low, x minus 2 squared times d high. D high, it's probably easier if we just distribute this again and call this x squared minus 4x as the top instead. So now d high would be 2x minus 4 instead of having to do a product rule with all that. Minus the high, x squared minus 4x. D low, we got to do a chain rule here. Not a tough chain rule. To the first times through the inside is 1. All over the bottom squared. So that's x minus 2 to the 4th. Now let's see, we can factor out an x minus 2 from each of these. And we can actually take a 2 out of this guy as well. So we can factor out a 2x minus 2 from each thing. 2x minus 2. Don't forget we've got 2 of them here. So we're going to have one of them left. So when we factor that out, we've got one of these x minus 2's times this guy, which factored into x minus 2. Oops. So another x minus 2. My x's aren't showing up so well here. Minus, we factored out the 2. We've factored out the x minus 2. We've just got x squared minus 4x. All over the bottom to the 4th. So this x minus 2 and one of those are going to cancel and leave us with 3. So we're left with 2 times, let's see, that'll be x squared minus 4x plus 4 minus an x squared plus a 4x. So So the x squareds are going to cancel. One of them's plus, one of them's minus. We got a minus 4x and a plus 4x. So we're getting 2 times 4 is 8 on top. So we get 8 over, I probably don't want to be sloppy and leave that off, x minus 2 to the third as our second derivative. All right, so now we want to say, where does that equal 0? Well, the top never equals 0. The bottom equals 0 at exactly 2, which we already said was a vertical asymptote. So if we take a look at, let's see, our number line here, it's not going to be a very big number line. We just have 2. 8 we can put on, that's always positive. The bottom we've got x minus 2 to the third. If we plug in a number below 2, it's negative. Above 2, it's positive. To the third, it's not going to change the sign. So that means the second derivative is negative and then positive, which means our function will be concave down, concave up. We don't have any points of inflection because this is a vertical asymptote. So now let's try and sketch the graph. So let's remember, we've got a vertical asymptote at 2. So here's 2. And we've got a vertical asymptote there. Can't draw straight lines on this. And let's see, what other points do we have? 0, negative 2 is a max. And 4, 6 is a min. So let's see, 4, 6. Let's say this is 6 right here. And 0, negative 2. Right there. So this is going to be a min. This is going to be a max. I draw those just to remind myself. We've got the vertical asymptote here. And I think that was it for as far as points went. All right. We didn't have any symmetry. No horizontal. We do know that we're going up to the right and down to the left. All right. So we start off increasing until we get to our max at 0. And then we decrease to our vertical asymptote. And we spend that time concave down. So we're increasing and concave down. It's almost a straight line, really, but that'll do right there. Remember, we're going to go to negative infinity, too. And then, let's see, we're going to be concave up and... wrong direction. Then we're going to be concave up and decreasing and then increasing after the point. So we're going to be coming down the vertical asymptote, hitting that point, and then we're going to be going up from there. Right, so that's what our graph's going to look like, and there's a picture of it. Voila. Yep, that's it. All right, another example. So again, what can we get from the original function here? So we're going to look for intercepts. So we can plug in x equals 0 to get our y-intercept. We get 0 on top, so we're getting the point 0, 0. We get square root of 2 on the bottom. All right, if we set it equal to 0, we get the same point. So this is our x and y-intercept. The origin, that's our only intercept. Symmetry, if we plug in a negative number, like a negative for x, we're going to get negative x over the square root of negative x squared plus 2. Or in other words, we're getting negative x over the square root of x squared plus 2, which is negative g of x. So that means it's an odd function. And that means the first quadrant and the third quadrant will match. The second quadrant and the fourth quadrant will match. All right, our domain, let's see. I don't think we have any domain problems. All right, so x squared plus 2 has to be greater than 0. Left off the 2 there. But that's not a problem because that's akin to saying x squared has to be greater than negative 2, which it always is. So our domain is from negative infinity to infinity. We don't have any problems there. We can't make the bottom equal to 0. So we have no vertical asymptotes. We can check for horizontal asymptotes though. So we take the limit as x goes to infinity of x over the square root of x squared plus 2. Let's see. This is equivalent to x over the square root of x squared. Highest power on top and bottom. Square root of x squared is really the absolute value of x. And as we go to positive infinity, that's just x. So this is just 1. So we get a horizontal asymptote. Y equals 1 as x goes to positive infinity. And as we go to negative infinity, it is going to be slightly different. Again, it's going to be equivalent to x over the square root of x squared. This is the same thing as the absolute value of x down here, but as we go to negative infinity, that does change our sign. So that's negative x. So that means we get negative 1. So y equals negative 1 is our horizontal asymptote here as x goes to negative infinity. So from one direction we'll be down at negative 1, the other one will be up at positive 1. So I think that's everything we can get from our original function. So now let's check out our derivative. So we got to take the derivative of that. We've got another quotient rule. Those are really the fun ones to do anyways. So we can write this bottom as x squared plus 2 to the 1/2. All right, so that'll help us when we take the derivative. So we get x squared plus 2 to the 1/2. Low, d high, minus derivative of x squared is just 1, minus high, d low. So we'll bring down the 1/2. We've got x squared plus 2 to the negative 1/2 times root of the inside, which is 2x. The 2 and the 1/2 are going to cancel. All over the bottom squared. So we get the square root of that squared. We just get x squared plus 2. It's too good to last. It's not going to last. All right, so now we can factor out some stuff from the top. Each one of them has an x squared plus 2. The lower exponent is negative 1/2. So that's what we're going to factor out is x squared plus 2 to the negative 1/2. When we factor that out from this one, in essence, we're dividing by it. And when we divide, we subtract exponents. We're going to get 1/2 minus negative 1/2. Those negatives will cancel out, and it'll be 1/2 plus 1/2 is 1. So we'll get x squared plus 2 to the first, or just x squared plus 2. This guy we factored out completely. We canceled out the 2 and the 1/2, and we just got minus x. So minus x squared all over x squared plus 2. All right, so now this guy to the negative 1/2 will come down here with this guy. So he'll come down to the bottom and change the positive 1/2. So we'll get 1/2 plus 1 is 3/2. And these x squareds cancel. So we're getting 2 over x squared plus 2 to the 3/2. All right, now the top never equals 0, the bottom never equals 0, so we have no critical values. All right, that doesn't mean we don't have increasing or decreasing. It just means it's either always increasing or always decreasing. So if we look at the sign of g prime, here's our number line, no points. If we just plug in any value, like say 0, we get 2 on top, we get 2 to the 3/2 on bottom. That's still positive. It's always positive. That means g of x is always increasing. All right. So we got no relative mins, no relative maximums, no decreasing areas, just always increasing. All right. We can also try and pull out our second derivative right now. So if we want, we can rewrite that as, just bring the bottom up so we don't have to do a quotient rule again. X squared plus 2 to the negative 3/2. So now our second derivative, 2 just stays in front. We bring down negative 3/2, so we get 2 times negative 3/2. Leave the inside the same to the one less exponent times root of the inside. All right, so this 2 and the 2 down there are going to cancel. We got negative 3 times 2x, so that's negative 6x. This guy, negative exponent, we can move him back down to the bottom. X squared plus 2 to the 5/2. All right, now we got the 0 back on top here, so this will equal 0 when x equals 0. So we do have a number line happening for this guy, for the second derivative here. And 0 is the only point we really need to look at. We've got negative 6x. The bottom is always going to be positive, but I'm going to write it anywhere. X squared plus 2 to the 5/2, always positive. If we plug in a negative number, negative 6 times negative 1 is positive. Plug in a positive number, we get negative. So that means our second derivative is positive and then negative, which means our original function is concave up, concave down. So 0, 0, which we found from before up here, that is a point of inflection, changing concavity there. All right, so now I don't have any room to draw it here. So let's go to the next slide and let's try and draw. So remember, we got 0, 0 as a point. We're always increasing, and we've got some horizontal asymptotes we can draw. And then don't forget our symmetry there too, odd function. All right, so let's try and draw this. So we got 0, 0. We've got, let's call this 1. So we're counting by 1/2 here. Let's call this -1. We're going to 1 as we go to positive infinity. We're going to -1 as we go to negative infinity. So we're coming from this asymptote, going to that asymptote. We're always increasing, so we're always going up. And let's see, what's our concavity? So we're concave up to start until we hit 0, and then we're concave down afterwards. So we should have this shape, and then we should have this shape. All right, so coming off the asymptote and concave up through the point. Now we're concave down and to the other asymptote. And that should be our graph. That should be g of x. All right, there it is. It takes practice to draw these guys. All right, so that was 2 more examples. We'll call it quits for now because I think we've gone a long time already. If you want, we can do another example in class, okay? And this is the end of the section, so get the homework assignment done for this. It's good practice, and then we're coming to another test.